Hello, my name is Davi, and today I'll be presenting a pitch on my master's degree research project entitled Development of a Three-Dimensional Primary Bovine Hepatic Spheroid Model for Drug and Nanomaterial Metabolism and Toxicity Studies. So, why hepatic? Well, the liver plays a central role in drug and other substances metabolism and detoxification. And why spheroids? Because traditional in vitro pharmacological studies rely on two-dimensional hepatocyte cultures, which have major limitations that can be overcome by 3D models. In recent years, 3D hepatic models such as spheroids have emerged as more predictive systems. These models better preserve cell-to-cell interactions, tissue architecture, and metabolic activity over extended culture periods. As a result, hepatic spheroids are increasingly recognized as valuable tools for drug metabolism and hepatotoxicity assessment. Despite these advances, most existing models are based on human or murine hepatocytes, and there is a clear lack of standardized models for livestock species such as cattle. This gap limits species-specific pharmacological studies, veterinary drug development, and the assessment of nanomaterials used in animal health. Having said that, our main hypothesis is that spheroids formed from primary bovine hepatocytes are capable of maintaining essential liver functions and responding to toxic stimuli in a reproducible manner, making them a suitable model for metabolic and toxicological studies, including the evaluation of nanomaterials such as nanoencapsulated antibiotics. Our objectives are to develop and characterize a three-dimensional model of bovine hepatocytes for metabolic and toxicological studies, specifically by adapting pre-existing protocols for human or murine cells, characterizing the spheroid's morphology, histology, and function, and finally sum everything up with metabolic and toxicological assays using a non-encapsulated drug as proof of concept. As our experimental design proposition, we'll start by harvesting bovine liver tissue from slaughterhouses and going through with simple digestion and purification to isolate the desired cells, following well-established human cell protocols. Then we'll follow another established human cell protocol to form the spheroids by centrifugation in neutral low attachment 96 well plates so that the cells only have each other to grasp and then form a sphere. The spheroids will be cultured in physiological conditions until they are compressed and ready for evaluations. The spheroids will be morphologically characterized by optical and electron microscopies in order to measure their diameters, compression behavior, and general morphology. As for the histological evaluation, routine and immunohistochemical techniques shall be applied with specific hepatic markers to better understand the composition and function of spheroids. And talking about function, the functional characterization will consist of specific metabolites, quantification, as enzymatic activities, and long-term stability and viability. To conclude the project, we will elaborate a proof of concept assay using a comparison between traditional and metronidazole and its non-encapsulated version, which both have antibiotic and antiprotozoal activities and are metabolized in the liver. For that, we'll evaluate the spheroid's viability after the exposure periods by different means for a robust response. And finally, assess the depletion of the parent compounds using mass spectrometry to evaluate the metabolic function of the models. So, we expect this proposed model to be more predictive and more similar to in vivo conditions. With that, we hope to boost the advancement of new approach methodologies, to reduce the usage of animals in pharmacological researches, and to improve pharmacological and nanotechnological veterinary research. Thank you for your time, and here are my references.